Hello everyone, this is Maverick Paul, the chemistry guru. Now in this video, we want to discuss the strong oxidation of alkene and alkyl benzene using this example. Now let's take a look at this question. Compound G reacts with hot acidified KMnO4 under suitable conditions. So compound G, we notice we have benzene and we have alkyl groups attached to my benzene. And we actually also have my alkene functional group that is present. So question is asking what is the most likely organic products formed from this reaction. And we have four options A, B, C, D. Now, if I consider hot acidified KMnO4, this will be the reagents and conditions for strong oxidation. And in syllabus, we actually will be able to oxidize alkene functional group as well as alkyl benzene. So before we run through and determine the product, it is a good idea to recap strong oxidation of alkene and oxidation of alkyl benzene. Now, if I consider strong oxidation of alkene, I know that the C double bond C will be broken. So this is considered an oxidative cleavage, or we can just say that the C double bond C will be chopped off and I'll have two different carbons, and what each of these carbon will become, it depends on the groups that is attached to my alkene carbon. So we have three scenarios here. If my carbon is attached to two R groups, this will be oxidized to ketone. If the carbon is attached to a hydrogen and an R group, then this will be oxidized to acid. If the carbon is attached to two hydrogen, this will be oxidized to CO2 and water. So depending on the groups attached to my alkene carbon, this can be either oxidized to ketone, acid, CO2 and water. The other oxidation involving alkyl benzene. Now, oxidation of alkyl benzene is interesting. The criteria for your alkyl benzene to be oxidized to benzoic acid, the carbon that is directly attached to benzene just need to have minimum one hydrogen. So the carbon has one hydrogen, two hydrogen, or three hydrogen. Then the carbon which is directly attached to benzene will be oxidized to benzoic acid. Effectively, this will mean that the rest of the bonds will be broken. And if there are other groups that is attached to my carbon that can be oxidized to benzoic acid, it will be broken off from your compound. Most of the time, what we are interested in is the benzoic acid portion, because benzoic acid in itself, it has a very big molar mass. So usually this guy will be the dominant compound that we focus on. So once we have talked about this strong oxidation of alkene and alkyl benzene, what we can do is now we can look at compound G and try to deduce what it will be oxidized to. Compound G is here. Maybe let us look at the CH3 group first. We know that this carbon, it is a methyl group. Remember, criteria for oxidation of alkyl benzene is the carbon directly attached to benzene need to have minimum one hydrogen. So this is a CH3, definitely it has the criteria. We know that this CH3 group will be oxidized to acid group. Now, how about this carbon? This carbon is attached to three methyl groups, and my carbon here does not have any hydrogen. So it wouldn't undergo any oxidation. We will have to leave this quaternary carbon alone. There will not be any oxidation for this quaternary carbon. Now, this carbon here with two hydrogen, this is a CH2, and again it has the criteria. Carbon that is directly attached to benzene has a hydrogen, so this carbon has two hydrogen. Yes, this will be oxidized to benzoic acid. So this will mean that the other bond here, this carbon-carbon bond will be broken. So the blue carbon can be oxidized to benzoic acid. So we do have to take note this carbon-carbon bond will be broken. Now, how about my alkene carbon? My green carbon, which is my alkene carbon. You notice this carbon is attached to an R group, which is benzene, and a hydrogen. So this actually falls under your scenario 2, where your carbon is attached to an R group and a hydrogen. We know that this guy will be oxidized to acid group. So usually what I'll do is I'll put an A for acid to annotate that this will be oxidized to acid functional group. Now, by right, this pink carbon, it is also an alkene carbon. So according to the same deduction, we won't expect this pink carbon, which is my alkene carbon, is attached to another carbon, that is my R group, attached to a hydrogen. So this carbon, by right, should also be oxidized to my acid group. But you notice what we have for this pink carbon, there is a carbon-carbon bond broken here, involving my alkene. There's also a carbon-carbon bond broken here, involving the oxidation of my alkyl benzene. So this pink carbon actually will be isolated, it is by itself, and that one carbon will be oxidized to CO2 and water. If it is one carbon by itself, it will be subsequently oxidized to CO2 plus water, and therefore you notice what I've written here is the CO2 plus water, this carbon from carbon dioxide actually belong to this pink carbon here. Now, more or less we have already determined what G will be oxidized to. I know that this carbon will be oxidized to acid group, the alkene carbon will be oxidized to my acid group, which is here. This other alkyl carbon will also be oxidized to my acid group, which is here, and my quaternary carbon, again, it doesn't undergo oxidation, so we will just leave it alone. So we will expect on oxidation using hot acidified KMnO4, the product will look something like this. Then now what we can do is we can compare this with my options A, B, C, D, and we notice that D will be the answer to this question. Alright, so that was the discussion involving this question targeting the oxidation of alkene and alkyl benzene. So if you have learned something useful from this video, please give me the thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. I'll see you next week.